We're going to look at equivalent rates of interest first. So we're going to start off by doing this example. Determine the interest rate compounded monthly that is equivalent to 2.3% compounded semi-annually. Okay, so first I'm going to take the interest that's there, 2.3, and I'm just going to divide it by 100, and I'm going to get 0.023. Okay, that's semi-annual, and we want a monthly interest rate. We want to convert it. So we're going to use this fancy formula, I equals 1 plus S over 2, which is the semi, to the 1 over 6 minus 1. And now we're going to plug in this I. It's actually a semi-annual I, so we're going to plug in that I that we have right there. So this one here, maybe I should call it S, so I'll just go S equals. So this is the S. So this is really S equals that goes in there. So I equals bracket 1 plus 0.023 over 2 to the power of 1/6, subtract 1. Now I'll show you how to put this in the calculator. You actually don't need the square brackets on the outside. I'm not sure why I put them in the formula there. We're just going to avoid them right now, so I'm going to turn this on and clear. So let's take a look. So we're just going to put the round bracket 1 plus 0.023 divided by 2. We're going to now close the bracket, so it's 1 plus that, and use the exponent key. And in a bracket, we're going to go 1 divided by 6, close the bracket, and subtract 1 at the end. So that's our formula. We go equals, and you get 0.001908. So 0.001908. Okay, alternatively, to put it in the calculator, another way, maybe you can just go 1 plus 0.023 divided by 2. You get an answer, 1.0115. Then you take that, you can use the exponent key, bracket 1 divided by 6 goes in here. Okay. And then you minus 1, and you get the same answer that way. 1 divided by 6, let's see what that is. So we know it's 0.166666666. So another way, maybe we got 1 plus 0.023 divided by 2, and then exponent 0.166666667, enter, and then subtract the 1, and you also get the same answer, the similar answer. You're going to move on to the next question. So that's how you find I. So the next one here, let's flip the page over, number 2. And it'll clear up in a second, so the camera's focusing. Number 2. Determine the monthly payment of a mortgage which has a $560,000 and it's amortized over 5 years at 2.5 compounded semi-annually. So first I. So we're going to use that formula right away. We're going to use the, let's use the bracket though, 1 plus, so let me write this out, 1 plus S over 2, find I, to the 1/6 minus 1. So you don't have to write the square bracket. Okay, so 1 plus S we're going to put as a decimal. So we're not going to use 2.1, we're going to use 0.021 all over 2, okay, to the 1/6 minus 1. And now I'm just going to apply the calculator here. So hopefully on the last one you figured out how to do it. If not, I will just do it the one way this time. 1 plus 0.021 divided by 2, close the bracket, to the power of 1 divided by 6, close the bracket, minus 1. So I got my interest rate of 0.001742. So let's write that here. 0.001742. That's the 4 decimals. Let's go 1, 2, 3, 4 digits. Okay, N. So N for the formula here. So N is 25 years, but it's 12 times. So you're going to pay this mortgage for 25 years times 12. So over here we're going to go 25 times 12, and you get this huge number, 300. So you get 300. Okay. Now we use the present value. So the current value of the mortgage is 560,123. Now we're going to use that PV formula. So PV equals R 1 minus 1 plus I to the negative n all over I. PV is 560,123 equals R. Now in here we go 1 minus, we use that interest rate we found. That's the only difference than before. To the negative 300 all over 0.001742. Now we're going to get 56000 1, 2, 3, 4 equals R. And we're going to have an answer here. We're going to put all that in a calculator. We're going to get an answer there. Let's figure out what that answer is. We're going to put bracket 1 minus bracket 1 plus 0.001742, close the bracket, to the exponent negative 300, close the bracket again, divided by 0.001742. 233.498, and we're going to divide both sides by 233.498. We'll divide this side by 233.498, and I'm just going to move over here, and we're going to get R equal to, divide the two numbers, 561,212. So 500, oh, didn't go in, 1, let's clear that. 561,212 divided by 233.498. 233.498 equals, so it's hard to see there. So our payment's 2,398 and 31 cents. 2,398 and 31 cents. And then you put a little sentence. Therefore, the payment, or the monthly payment, is 2,398 and 31 cents. We're going to go on to B part down here. Okay, what is the interest paid on the mortgage? So we know that's our payment. Let's figure out the interest. So we do 2,398.31. We have 300 payments, so our N is 300. So we're going to multiply by 300. So up here, 300 payments. So we're going to figure out how much money here is going to go. So let's go 2,398.31 times 300. So we're going to spend 719,493 on the mortgage. I'm going to subtract. So we're going to take 719,493, and our mortgage was for 560, and we're going to figure out how much interest was earned. So when we subtract the two, our interest is, let's take a look here, 71943, so 719,493 subtract whatever our loan was, 1, 2, 3. So we paid $159,493 in interest. Therefore, the interest is $159,493. That the bank here, so I wrote it out here, 15943, that the bank takes away, or whatever financial institute you have takes away from you in order to pay for your house.